All right, surface area and volume of a prism now, right? So this will be part 2 of 3 videos in this segment for today. But this is a special case here, and I wanted to make sure that I kind of give you a good example of this. So let's start reading right through here. It says find the area of one base, the lateral area, the surface area, and the volume of a right regular triangular prism. So let's just go back on some vocabulary here real quick, all right? What makes this a prism? Well, it's going to have 2 equal or congruent parallel bases. So right now what I want to do is I want to highlight my bases. So let's keep it going. Prism, 2 equal parallel bases. Triangular prism. What makes it triangular? Well, obviously our bases are triangles, but this is what I wanted to focus on right here. This is important. You must know that if a prism is regular, then its bases are equilateral and equiangular. The bases are perfect, okay? What makes this a right prism? Well, if we were able to pick this thing up and stand it up on its triangles, it would stand straight up, right? Which would basically make all of these rectangles. But I think the real important key to this question is the fact that the triangulars are regular triangles. So think about it. If each of the triangles are regular, then that means they are equilateral, right? Which means all 3 sides are the same. It's also equiangular. So guys, think about it. 180 degrees, we should know that all equilateral triangles have measures of 60, 60, 60. Okay? It's equilateral triangle. So the first thing they ask us to do is try to find the area of one base. Now this is important. We got to remember some special right triangle rules. So let's think back to when we learned our 30, 60, 90 rules. Okay? So basically, we were told that if you know the short leg, right, which is the one opposite the 30 is x, then the hypotenuse is 2x, right, the one straight across from 90. Then that leaves the side that is the long leg opposite the 60. That is x radical 3. All right, we got to remember that rule, those set of rules for this question here. So let's keep reading. All right, it has a base perimeter of 36 feet and a height of 20 feet. All right, let's label some things here. Base perimeter. So each of our bases are triangles. One base perimeter is 36 feet. So that means this plus this is 36. So I'm going to take 36 divided by 3 sides, and that's going to give me 12 feet on each side. Okay? 12 feet. Okay. And same back here, right? Because these two are congruent parallel bases. All right? So now if I want to find the area of one base, one capital B, I'm going to start with that. Well, I got to ask myself, what is the shape of the base? It's a triangle. So I'm going to use 1/2 lowercase b h, okay? Remember, big B, capital B, is the full area of one of these yellow triangles. What I'm going to do is label the triangles down here. Now, we already know that this is 12 and 12, but what we're going to do is we need the height of this triangle drawn right here, okay? Which is going to split this 12 up into 6 and 6, and the same thing down here. So let's look at our rules here, guys. 2x is the 12 side, right? So what would you do to 2x to go back to x? You would divide it in half. Well, look what happens. 12 cut in half is 6. Then we would take the short leg and multiply by radical 3 to get the height of the triangle. So 6 times radical 3 is going to give us 6 radical 3. Now I'm ready to find the area of one base. So now, capital B equals 1/2 times, guys, full base of the triangle. I'm not using half of it, full base. So the full length is 12. The height of the triangle is 6 radical 3. Okay, so one base area is going to be 1/2 times 12, which is 6, times 6 is going to be 36 radical 3 feet squared. Okay, again, formula, substitute, answer with a label. There's one of my answers. I'm leaving them exact, okay? They told me, right? Find the area. You know what? Shoot, doesn't say that in the directions, but guys, I want you to understand why we can leave this in exact form, all right? Next, I'm going to label this with feet squared. All right, cool. So the next thing I want to do is I want to find my lateral area, okay? Now, lateral area, I'm going to use green here. Lateral area is going to be the area of all 3 of these rectangles. But guys, if you go on your formula sheet, okay, and you look under the column for lateral area of a prism, not a cylinder, okay, lateral area of a prism, it's going to say use the formula LA equals pH. Well, let's remember that the P represents the perimeter of the base. Well, guess what? They told us that. Perimeter of the base is 36 feet, okay? They're also telling us that the height is 20, but I want to take a second here, and I want you to understand, where is the height on this diagram, okay? Big mistake, all right? This is not the height. Now, we know that this is 6 radical 3, but this is not the height of the prism. Remember that if you could take this prism and stand it up on its base, stand it up on the triangles, then the height is actually right here. The height of any prism is how far the bases are from one another, okay? So in this case, this is actually the height of the prism, okay? Picture picking that thing up and standing it on a triangle. All right, so here we go. So now I'm going to I'm going to write my formula, LA equals pH. The perimeter of the base was 36. The height of the prism is 20 feet. Okay, so I know that 2 times 36 is 72. So 20 times 36 is going to give me 720 feet squared. All right, so there's my second bit of information. And guys, that would be all of the area of that rectangle, 720 feet squared. Okie doke. So we're getting there. We're just about finished here. I just wanted to mention one thing to you, all right? As I label this net, I'm realizing I don't have everything labeled, right? So the height, if you could stand this prism up, the height would be 20 feet, okay? I'm going to put 20 feet on both sides, okay? But that 20 feet goes throughout. All right. Now let's remember that each side of the triangle is 12, 12, 12, right? 12 each. So that means going across the top here, if I unfold this, then I'm going to have 12 here, really 12 here, and 12 here. Okay? Watch this. 12 times 20 is 240. That's the area of this one rectangle. And guess what? Since the base is an equilateral triangle, all of these rectangles will be the same. And guess what 240 3 times is? 720. All righty. So let's go try to wrap this up. So the surface area is going to be LA plus 2 capital B's, although we were using pH for lateral area, okay? I like that better. So now, guys, all we have to do here is basically, we know what the lateral area is. We just found that it's 720. I don't have to redo it, but I do have to be careful here. One base area is 36 radical 3. So we got to make sure that we include 2 triangles, not just one. All right, so I'm just about done here. My surface area is going to be 720 plus 2 times 36. That's 72 radical 3. Can I combine these? Are these like terms? They are not. So I am going to leave this separate as 720 plus 72 radical 3 feet squared. Okay. Finally, and notice, guys, 3 steps, 3 steps, 3 steps. You got to show it each and every time. Volume for any prism is going to be capital BH. Be careful. That is the area of the base. So now I'm going to take the area of the base, which was 36 radical 3, and I'm going to multiply it by how tall the prism is. Okay, the distance between the bases, which will be 20. Okay? All righty. So let's see. So in this case here, I'm going to get 720 radical 3 feet cubed. Alrighty, so I just want you to understand here that this is pure coincidence. All right, we don't always get like these same numbers here, right? Don't think that that always happens, but that is how this one happened to work out. All right, ladies and gentlemen, area of one base, which is one yellow triangle, lateral area, which would be these 3 rectangles here, surface area, 3 rectangles and 2 base areas, and finally your volume will be the area of one base multiplied by how tall it is. All right, hope this helps, guys.